So this lesson is on dividing radicals. And like multiplying radicals, we're going to focus on what's in front and what's underneath and handle them separately. So when I look at dividing, a quick reminder that a fraction line means dividing. Do you see the coefficients or the numbers in front of the square root? We're going to look at them separately. Do you see the numbers underneath the square root? We're going to look at those separately, and then we'll put it together. So obviously 12 divided by 2, no biggie. How about 160 divided by 5, no calculator? Go for it. Is that in your head, or do you write that down? Or do you wait till I give it to you? I need to know 160 divided by 5. I don't know if you can do that mentally. Done. Ta-dum. Keep going. Kimberly, what's 150 divided by 4? 160 divided by 5? Mentally? Nice. How did you do that mentally? Any trick? You just kind of know it? All right. That's good. You have a good brain. 32. Is that done, or is 32 not prime? Prime, not prime? Not prime. What's the largest perfect square that goes into 32? That's right, 16. 16 times what? And the square root of 16? 4 times 6 in front? What's the answer? Beautiful. Here we go. So it doesn't matter in terms of what radical we're looking at, but they do have to be like radicals. So again, do you see the numbers in front? Does 9 go into 36 evenly? Good. Look underneath. We divide what's underneath. How about 1250 divided by 2? Well, half of 1250. I bet you could do that easier. Half of 1200, half of 50, right, Chris? 625, is that right? Okay, keep going. The fourth root of 625. Can you simplify it? The fourth root. Or, is there a number 4 times itself that equals 625? There is. What's the number? So 5 times 5 times 5 times 5 is 625. So it is a perfect fourth. And then 4 times 5 is 20. All right, try number 3. Number 3, there's nothing in front other than 1. No coefficients to worry about. So just underneath. I need to know my exponent rules. When you're dividing and the bases are the same, what do? With the subtract the exponents. So like 3 take away 2. That's x to the 1. And 9 take away 5 is y to the 4th. Okay, do the last step. And then I'll do it. Can you simplify that? Thomas, do you remember the square root of y to the 4th, how I simplify that?
Yeah.
What do I do? Yes. Divided by? The number is called 2. Yeah. Yeah. So y to the 4th, how do I do the square root with an exponent? Is I divide the exponent by 2. So y to the 4th divided by 2 is now what? Y squared, and root x is prime. I can't simplify it. Perfect. Thanks, Thomas. Number 4. Try it. Then I try it. Then we're going to talk about rationalizing the denominator, what that means. And then we're going to look at some binomials on the backside to know how to do the conjugate, things like that. So try number 4. Davian will bring you up to speed. So when you look how you did the first step, does it match? Are you careful about the radical sign? Like, are you aware it's cube roots? You make sure there's a little 3? Or are all radicals square roots in your head, right? 28 divided by 4. Negative 16 divided by 2. 6 take away 1. Yes? Is it okay that a cube root is negative?
Yeah.
Is that imaginary?
No.
So that's okay. So what is the cube root of negative 8? Negative 2 times 7 is, all right, do you see this m to the 5? M to the 5 can be broken down as m to the 3 and m squared. Remember dividing by 3? So 3 divided by 3 is just 1m, and then what's left behind is m squared. Number 5. Here's an example where the square root goes over the entire fraction. We don't have one on top, one on the bottom, just one big square root that belongs to both. So, does 16 go into 48 evenly? Yep. How many times? And that's prime. We move on. Number 6. Isn't that crazy? 48 divided by 16 is 3, and the square root of 3 is prime, so it's over. Next question. Here's an example where it's not advantageous to simplify it first. Do you know why? I know the cube root of 27, right? So let's just do it. So this means the cube root of 40 over the cube root of 27. So I already know the denominator is 3. Is there a perfect cube that goes into 40 evenly? That's 8 times 5. And then the cube root of 8 is 2. Cube root of 5 is prime over 3, and it's done. Number 7. We're going to practice together till we get it. You're going to practice on your own with me if you need to. And then you'll do great on the quiz tomorrow. Number 7. You then me. So I have two choices. I can divide, but that didn't lead me anywhere, right? Like 7 into 64. And are the bases the same? So dividing didn't help me. So instead I'm going to separate. So the cube root on top and the cube root on the bottom. So I have to make a choice. Does it make sense to divide first or to separate the radical? Those are your two options, right? And if one option doesn't work, you go to the next option. Now, the cube root of 7, that's prime. But x to the 5th, do you know how I can write that as? As x cubed times x squared. So the cube root of x cubed is x, and what's left behind that's prime is 7x squared. How about the denominator? What is the cube root of 64? 4, right? Because 4 times 4 times 4. And then is 6 okay? What's 6 divided by 3? And that's it. Nothing can be simplified further. Try number 8. Decide, are you going to separate the fourth root? Or are you going to divide first? Are you able to see that? The fourth root of 81 is 3. And then 32 I wrote as 16 times 2. So the fourth root of 16 is 2. And then what's left underneath the fourth root is 2w. And that's it. Are you okay with dividing and seeing the two paths? You either divide first and then do it, or you separate it, top and bottom, and then work with them separately. Hey, have you heard the word rationalizing the denominator? Have you heard of that before mathematically? I bet you have. Do you know that when you have an irrational number in the bottom, what's an irrational number? Do you know the exact value of an irrational number? No. A rational number you can write as a fraction. You know exactly where that is in a number line, right? Like examples of irrational are things that don't simplify, right? That a radical is still there. Sometimes we need to write the denominator so it's a rational number. So when I look at the denominator, root 5 is what? Irrational. I want that to be a rational number. The work that we're going to do is called rationalizing the denominator. So what does it mean to rationalize the denominator? To make the denominator a rational number. That's what we're doing. So what's irrational, we're going to multiply top and bottom times. So whatever I do at the top, I can do the bottom and it stays the same. So what did I do? I took the irrational number on the bottom, and what do I do top and bottom? Multiply. 3 times root 5 is just 3 root 5. Can you follow this? I can multiply in any order. It's better to go right to left. What's root 5 times root 5? 5. And 5 times 2? Done. On to 10. Step 1. Can you reduce this fraction down? 8 over 15, or is it in lowest terms? Good. It's in lowest terms. Next, separate the square root, top and bottom. Is there anything there that is simplifiable? Root 8 or root 15? Root 8 is 2 root 2. All right. Is root 15 an irrational number? Yes. How do I make the denominator rational? Take the irrational number, and what am I going to multiply top and bottom times? So the easy part here is the denominator. Root 15 times root 15 is 15. Follow this. Root 15 times root 2 is root 30. And then what number goes in front? And don't go 60, right? What's under the square roots multiply. What's in front multiply. It feels like you should simplify root 30, but it's not. So it's a feeling that needs to go away, right? Is there a perfect square that goes into 30 evenly to reduce it down? But it feels like it, doesn't it? But it isn't. So that's the answer. 2 root 30 over 15. Let's turn the page. Okay, step 1. Is there anything simplifiable here? Is there anything simplifiable in number 11? What's root 12? 4 times 3, but it's 2 root 3, right? And 2 times 3 is How about 6 over 4? What's a better way to write that? 2 over, not 2 over, but 3 over 2. Is root 7 irrational? That's a 3. Yes, so what do I multiply? Just the irrational number, top and bottom. So what's root 7 times root 7? 7. And 7 times 2 is, okay, what's 7 times 3? So on top is root 21. You know what you're tempted to do? Is to think that 21 and 14 would reduce down. And why can I not do that? Because one is under a square root sign and the other one is not. So they're not like numbers like that. Yay? 12. Simplify. Then multiply by the irrational number on the bottom. Try. Number 12. So 28 is 4 times 7, right? 8 to the 5th would be 8 to the 4th times a. So the square root of 4 and the square root of 8 to the 4 is 2a squared. What's left behind is 7 and a. The denominator is prime. I can't do anything. So that whole irrational expression, root 3a, top and bottom. So root 3a times root 3a is 3a, 2a squared, and then 7 times 3 is 21, and a times a is a squared. One more step. What is the square root of a squared? So that makes how many a's now in front? One more step. What do you see on the top and bottom? So if I reduce it down, the a makes the a cubed an a. So it's 2a squared, the square root of 21 over 3. All right, 13 is a little different. What makes 13 a little different is that the numerator has two numbers adding or subtracting. This is a binomial number. So, first step is there anything simplifiable? So root 8 can be written as 2 root. So first step, look, is there something simplifiable? Next, are these like radicals on top? Can I combine them together? What number don't you see that's in front of the second one? So 2 subtract 1 is 1 root 2. And what's on the bottom? Hey, that's done. So anytime the same number on top and bottom, the answer is 1, no matter how ugly you think it looks, right? Over. 14. Let's practice together, and then I'm going to give you time after. Anything simplifiable, first step. So root 12 can be written as 2 root 3. Next, do you see the irrational number in the bottom? That irrational number is root 3. So only the irrational number, top and bottom. Root 3 times root 3 is 3, and 3 times 2 is 6. Be careful here. You have to distribute to both numbers. What's 3 root 2 times root 3? Is 3 root 6. And what's root 6 times root 3? Root 18. All right, anything simplifiable here? What's 18? 9 times 2, which is 3 root 2. One last step. Is there a number? Look at not under the square root. Look at the other ones. Is there a number that goes into all of them evenly? All three numbers. 3, right? So 3 divided by 3 is 1 root 6. 3 divided by 3 is 1 root 2. And 6 divided by 3 is 2. Number 15. Now, these are the good challenges. Do you see that we have a binomial in the denominator? I can't go root 2 top and bottom. If you have a binomial, you can't just use the irrational number. You need both, and what we're going to use is what's called the conjugate. Do you remember that from like 100 years ago? What does the word conjugate mean? Instead of 4 plus root 2, what are we going to do? 4. So when we have a binomial on the bottom, 2 numbers, you can't just use the irrational number. You have to do the conjugate, or else it will stay irrational on the bottom. So what's the conjugate of 4 plus root 2? Good. So why did I do that? Because I had a binomial in the denominators. Yes? Okay. So can we multiply the top out? 4 times 4 is 16, and 4 times root 2 is 4 root 2. Now this one is easier than it looks. Because it's a conjugate, I don't have to FOIL the inside part. Just first and outer. That's it. So what's 4 times 4? And what's root 2 times negative root 2? And I don't need to worry about the middle numbers because they will cross out. That's why we did the conjugate. So the middle number would eliminate. So 16 take away 2 is 14. Is there an obvious number that goes into all 3 numbers? 2. So 16 divided by 2, 4 divided by 2, and 14 divided by 2. That's it. Done. I want to make sure when you go to Alex, right, and you see this, that you have the skill, right, to be able to simplify it. Look at 16. Do you see a binomial on the bottom? Yes? I need to use what's called the conjugate. So what's the conjugate of 6 subtract root 5? Top and bottom. Can you distribute the 2? 2 times 6. 2 times root 5. How about the bottom? 6 times 6 is? And because they are conjugates, I just have to go last times last. And the middle numbers will eliminate. So I get 12 plus 2 root 5. 36 take away 5 is 31. Is there a number that goes into all 3 numbers evenly that would reduce it down? No. Done. Number 17. We always look to see, is there something simplifiable? Are they prime? They all are prime. Do we have a binomial in the denominator? So what's the conjugate of that? 1 plus 4 root 2. 1 plus 4 root 2. Root 3 times 1. Be careful here. Root 3 times 4 root 2. So like numbers you can multiply. So 3 times 2 makes it 4 root 6. The denominator, we just have to go first times first, which is 1. And then last times last, but we've got to be careful. How do we multiply those 2 numbers together? Well, negative 4 times 4 is negative 16, and root 2 times root 2 is 2. Do you see how I multiplied 4 root 2 times 4 root 2? 4 times 4, right? There's the negative 16. Root 2 times root 2 is 2. I know you know this, that 16 times 2 is 32. So you have root 3 plus 4 root 6 all over negative 31. And there's nothing to simplify that. This one's going to be the most challenging. Do you know why the last 3 are the most challenging, at least in terms of work? Is because we have a binomial on top and a binomial on the bottom. If they are two binomials but not conjugates, we have to FOIL to be able to do it. So we'll do it together. So look at the denominator. What's the conjugate of root 5 plus root 3? Root 5 subtract root 3. That's called the conjugate. But I have to do that top and bottom. So do you see the two numerators? In order to multiply that, I'm going to draw a box to FOIL. Or you can go first, outer, inner, last. And I have 5 and negative root 5. I have root 5 and negative root 3. Can you distribute all of that in the numerator? The denominator is simple. So root 5 times 5 is just 5 root 5. They can only go beside each other because they're unlike numbers. Root 5 times negative root 5, well, they're the same. So that leaves me with just negative 5. Negative root 3 and 5, they can only go beside each other, so that's negative 5 root 3. And then negative times a negative is positive root 15. So my numerator is going to be really long. There's no wrong way to write this. There are no like terms. Do you see that? There's no like numbers. So you can only just put them all beside each other. So I'll start with the rational number, but the rest, there's no right or wrong way to put them beside each other. You can go in any order, but recognize that they are all unlike. There's no way to combine those numbers together. The denominator, root 5 times root 5 is 5, and root 3 and negative root 3 is negative 3. So can you see 5 take away 3 will give you 2, and it's over. So did you see where 2 came from? Root 5 times root 5 is 5, and root 3 times root 3 is 3. That's where 2 came from. All right, 2 left. Number 19 and number 20. These take the most amount of time when you have a binomial over a binomial. So first, is there anything simplifiable? Second, you need to do the conjugate, top and bottom. The numerator is going to require us to FOIL, and if you find it easier to draw a square, an area model here, to be able to distribute, then that's what you do. So the conjugate, the numerator requires you to do some extra work to be able to distribute. The denominator should be simple. So 6, 2 root 7. Did you get negative 6 root 7? And then root 7 times root 7 is 7, times negative 2 is negative 14. We do have like numbers here, right? So how would I combine them together? 6 take away 14 is negative 8. And negative 6 plus 2 is negative 4 root 7. Now let's look at the denominator. What's 2 times 2? 4. How about 2 times negative 2? And root 7 times root 7. So, 4 take away 28. That's 28. 4 take away 28 is negative 24. What's the obvious number that goes into all three numbers evenly? And because they're all negative, we're going to divide by negative 4. That gives us 2 plus 1 root 7 all over positive 6. It's always better. If you can write it as a positive number, it's usually better. So what did I do as the last step? Is divided everything by negative 4. All right, last one together, number 20. I even started it for you. There is nothing simplifiable. So what is the conjugate? 3 plus 4 root 6. So, again, I'm going to give you a moment. Set this up. That's for the numerator. The denominator should be simple, where we don't have to FOIL. Patience. Grasshopper. All right. So 8 and negative root 6, 3 and 4 root 6. So we have 24, negative 3 root 6. 8 times 4 is 32 root 6. And then negative root 6 times root 6 is negative 6 times 4 is negative 24. All right, so let's put this together. Obviously, 24 and negative 24, they eliminate. Are these like radicals where you can combine them together? So 32 take away 3 is 29 root 6. Let's look at the denominator. 3 times 3, that's 9. Negative 4 times 4 is negative 16. And root 6 times root 6 is 6. So 16 times 6 is 96. So 16 times 6 is 96. 9 take away that would be a negative answer, and it's 87. Would you believe me if I told you that 29 goes into 87 evenly? I know you wouldn't. It does. Do you know how many times 29 goes into 87? 3. So 29 goes into 87 3 times, so it's root 6 over negative 3. That's it. Lesson on dividing, right? GMath, over, done. Out.